Welcome to the video lecture series on formal languages and automata theory. This is Dr. K. N. Sopalu. And in today's video lecture, we will be discussing about construction of context-free grammar for a specific string pattern. So now, there's no need to discuss much about the definition of context-free grammar. I will directly step inside the problem, and let us have to a context-free grammar for a language equal to a to the power of n, b to the power of n, where n greater than or equal to 0. So now we are supposed to construct a context-free grammar for this string pattern. So the minimum value of n is actually 0. That means there is a possibility of generating epsilon. So let us understand that what kind of language which can be generated from this string pattern. So when n is taken as 0, and the first answer is epsilon, and when n is 1, so you will get a and b. When n is 2, you will get a and b, and when n is 3, you will have triple a's and triple b's. So this continues in this fashion. Now we have to construct a grammar for this. That means we have to generate epsilon. There should be a possibility of generating AB, double AB, so on and so forth. So now we'll construct a grammar. So the best technique is you just take up the minimum string. First you generate a minimum string. So what is the minimum string at the initial stage? That is epsilon. So you generate a grammar like this. So S tends to epsilon. So now if this grammar rule is applied, you can only generate epsilon, but which is actually repeating here. So A's and B's is getting repeated, equivalently it is getting repeated. When there is one A, obviously there should be one B, and if two A's are there, eventually it should lead to two B's. So the how to generate this? Now we will have A on the left side, and S is a non-terminal, and B on the right side. So when you apply this rule repeatedly, you can generate as many as A's and B's together. So you can rewrite this rule. So S tends to A, S, B. Let us understand, make it as a rule number 1, and S tends to epsilon is rule number 2. Now let us emulate and apply this grammar in the corresponding string. Let us try to derive a string. So derive A, B, B. Now which rule you are supposed to apply? So we want to derive two A's and two B's. You cannot apply rule number 2 because eventually it leads to epsilon, so further it cannot be derived. So first you have to apply rule number 1. Now S derives as A, S, B. Now this falls under rule number 1. Now you have one A and one B. Now actually you have to get one more A and one more B. So again you cannot apply rule number 2. You have to apply rule number 1 because this S has to be derived further. That means this S has to be replaced by once again by ASB. So now if we replace that, so it can be derived as A, S, B, B. So again this applies for rule number 1. And what is required actually? You require two A's and two B's. And two A's and two B's has been already generated, but there is a non-terminal called as S. That S has to be eliminated. So which rule you have to apply? Now in this case you have to apply rule number 2. So when you apply rule number 2, it becomes A, B, and now apply rule number 2. And in short, you can write it as from the starting symbol S, you can derive AA, BB in 0 or more number of steps. So this is the meaning of this. When you put a star above it, this is called as S can be derived into AABB in 0 or more number of steps. So this grammar is perfectly a valid grammar. So welcome back to the video lecture series on formal languages and automata theory. Now, so welcome back to video lecture series on formal languages and automata theory. This is Dr. Gayan Sobalam. So we'll be continuing with the lecture on construction of context-free grammar, and we'll have another simplified examples on this. So now let us take that we want to construct CFG for L equal to a to the power of n and b to the power of n plus 1, where n is greater than or equal to 0. So now what this language pattern infers to say, that means if there is one n, one a, there should be two b's. If there is two a's, there should be three b's. That means number of b's should be always one more than a, which exists in this pattern. So we will generate a language now. So L equal to, so and n has been given as 0. That means if a of n is 0, then obviously that is epsilon. But b will be remaining 1 at least. So b, and another answer is if it is a, then you will have bb, and if it is double a, you will have triple b's, and if you have triple a's, you will have four b's. So this is the pattern which this language is going to generate. Now you assume that there should be number of a's and b's where b should be one more than a. So how will you do this in this case? And to do this, there should not be any concept called as epsilon here, because the minimum string is actually b. So let us assume that we first generate the minimum string. So generate s tends to b, that is the minimum string, bar, and you should always have number of a's equal to b's, where one more b should be existing over there. So you generate like this: a, s, b. So obviously finally this s non-terminal has to be replaced by some string. So that string is called as b. So the answer will be ABB. That means b will be one more than a over here. And you can rewrite this. So s tends to ASB is rule number 1. S tends to B is rule number 2. Now let us derive a string. Derive AA triple B. You have to derive this. So now which rule you have to apply to derive this? So if you directly apply rule number 2, then it stops over there. That means B is a terminal, you cannot derive further. So to generate A's and B's over here, you have to apply rule number 1. So S is derived as A, S, B. Now you apply rule number 1. Now in the second case, once again you need one more A. So S has to be derived by, once again, which rule actually generates A's and B's equivalently. So rule number 1 generates. So you cannot apply rule number 2, you have to apply rule number 1. So now this S can be replaced by another ASB. So it becomes AA, S, BB. So which rule you are applying? You are applying rule number 1 again. Now you have 2 A's and 3 B's, but here you have 2 A's and 2 B's, and finally this S has to be replaced. And if you want to replace S, then there is only one option which we cannot go further. That is only one rule applies over here, that is 2. If you apply rule number 2, S is replaced by B, and finally you will get the answer called as AA triple B. So AA, and this S is replaced by B, so the answer will be AA triple B. You are applying rule number 2, and you can write like this: S derives AA triple B in 0 or more number of steps. Now we will discuss another problem. So there is how to derive a CFG for a language L equal to a to the power of n, b to the power of 2n, where n is greater than or equal to 0. So when n value is 0, then it's apparently epsilon can be applied over here. So a to the power of 0 and b to the power of 0 always ends with epsilon. So the language which can be generated is L equal to, so minimum string is epsilon. And you can understand from the pattern of the problem, if there is one A, you will have two B's. That means number of B's will be double times the number of A's. So if we have one A, there will be two B's. And if we have two A's, there will be four B's. So on and so forth. It will be generated in this pattern. Now the rule to write this is, for every one A, you have to generate two B's. And there should be epsilon should be accepted. So you generate a rule S tends to epsilon, that is a minimum string, and then for every A you should have two B's. So now we can write like this: A and S actually generates BB. And you can rewrite this production: S is equal to A S BB, and S tends to epsilon. So this is rule number 1 and this is rule number 2. Now we can take this grammar and ensure whether it is able to derive the string. So in short, we will try to derive A, B, B. Now which rule you have to apply? The rule you have to apply here is rule number 1, because that only derives A and double B's here. So S derives as A, S, B, B. So obviously this is rule number 1. And now you have one A and two B's that has been already derived. So now this S has to be replaced by some other value where it will get eliminated. So if you want to eliminate S, then you have to replace S by epsilon. So if we replace S by epsilon, now the answer will become A, B, B. So this is rule number 2. So we can rewrite this: S tends to A, B, B. That means S derives ABB in 0 or more number of steps. Now we will discuss about regular expressions. Let us have an understanding how regular expressions can be replaced by a context-free grammar. Now you have to write a context-free grammar for a regular expression 1 star and 0. That means 1 can be repeated 0 or more number of times, but the expression always ends with 0. So let us write the language which can get generated over here. So if 1 is not generated, that means if 1 is generated 0 times, the answer is 0. If 1 is generated 1 time, the answer is 1 0. If 1 is generated 2 times, the answer is 1 1 0. And if it is repeated 3 times, it will be 1 1 0. So this is the answer, so on and so forth. So how will you write a context-free grammar to generate this pattern? All you want to know is which is repeating here. 1 is actually repeating and 0 is not repeating. So to do it, you just split into two portions. That means one star has to be taken as A and B has to be taken as 0. So we will rewrite this S tends to AB. Now A can be generated this A production can generate 1, 0 or more number of times. That means epsilon is possible and 1 should be repeated also. So how to write it? So A tends to, if we want to repeat 1, we can write 1 A, and if it is not getting repeated, then we can make it as epsilon. So this rule actually, this third rule, second rule is used to repeat the number of ones, and this epsilon is if it is not going to repeat, that means it ends with epsilon, then you have to apply this rule number 3. And B always have 0, it is not going to repeat. So what you have to do is you just rewrite B tends to 0. And this is rule number 1, and this is rule number 2, and this is rule number 3, and this is rule number 4. Now we will derive this string 1 1 0. So derive 1 1 0. So which rule you have to apply? You have to apply the first rule, S tends to AB. So rule number 1. Now A has to be generated 2 times. So you have to apply rule number 2. So if A is replaced by rule number 2, the answer becomes 1A B. So rule number 2. And you need one more 1 over here. So which rule actually generates 1 here? So rule number 2 once again generates. So this A has to be replaced by 1A. So again 1 1 A B, and this is rule number 2. Now after this, I don't want 1 to be repeated. But even though there is a non-terminal A which exists, that means I have to somehow get rid of this. The best way of doing that is this A has to be replaced by epsilon here. If that A is replaced by epsilon, the answer will become 1 1 B. And you are applying rule number 3. Now you want one more 0, and there is a non-terminal called as B here, and you can apply rule number 4 to replace this B by 0. So if you replace that, answer will become 1 1 0. So this is rule number 4. So you can rewrite this S tends to 1 1 0. S derives 1 1 0 in 0 or more number of steps. Now we will discuss a little bit advanced than this. Now we have to construct a CFG for a regular expression 0 plus 1 star. So what is the language which can be generated for this? So L equal to, so 0 and 1 may not be repeated. That means it may not occur at all. So 0 times when it occurs, the answer is epsilon. 0 may occur 1 time, 1 may occur 1 time, 0 may occur 2 times, 1 may occur 2 times, and 1 and 0 may occur, 0 and 1 may occur, 1 0 1 may occur, 0 0 1 may occur. So all possibilities should be considered. So what you have to do is, the best way of doing this is, you rewrite, you write the grammar which generates both zeros and ones repeatedly. So we'll make a start symbol here. Yes, yes tends to 0, yes. So this actually repeats 0 multiple times. Now I want to repeat 1. Now 1s. This one, this repeats 1 multiple times. Now nothing is repeated, then you have to use epsilon here. So s tends to 0s is rule number 1. S tends to 1s is rule number 2, and s tends to epsilon is rule number 3. Now we'll derive this string 1 0 1. We have to derive the string. So derive 1 0 1. Now how to do this? First we want to derive 1. We will derive from left to right. So the left side you should derive 1. So which rule actually derives 1 here? Rule number 2 derives. So you have to replace s tends to 1s by rule number 2. Now after this 1 is generated, you have to use generate 0. So which rule actually generates 0? So rule number 1 generates 0. So s has to be replaced by 0s. So it will become 1 0 s. So rule number 1. And after this you have to again need one more 1. So rule number 2 generates 1. So this s has to be replaced by 1. The 1 0 1 s. So rule number 2. Now you got the string 101, and you have to somehow get rid of this s. So s can be replaced by epsilon. So when you replace s by epsilon, the answer is 101, and this is getting replaced by rule number 3. So we can have s derives 101 in 0 or more number of steps. So thanks for watching the video. Have a good day.